fact that
Okay.
you mentioned the fact that the data may be searched online.
Yeah.
But I'm looking at our situation in Nigeria. How many institutes, learning institutions, or other stakeholders in the research development area that puts their data on for the activity in Nigeria online.
Okay.
So that's still a serious challenge to us. And then an individual data that is sourced individually may not be big enough for us to go through this machine learning modeling. Okay. So how do we go about this kind of challenge, or is there anything you may want to advise regarding this?
Thank you very much, Professor. So, and thank you very much for joining the program. That's Professor Taufik, so from the University of Ibadan. We are honored to have you on board and other professors also on seat. Thank you very much. And he happened to be Professor of Greek, so he's asking questions from practical point of view. Regarding the questions, yes, there is still challenges of data. However, when I talk about online data, I mean globally. You see, when we want to build machine learning model, the place to start is we may not have our data, but we want to have an understanding of what we want to build. So if we wait until we are going to have our own data, we will not make progress. So that is why we usually start from somewhere, and that is we get data from online. There are a lot of repository all over the world. I mentioned Kaggle as an example, very popular. They even do competition there where they put data that are very tough to crack. And they say if people can do predictive solutions with excellent result, they put thousands, sometimes millions of dollars on such competition. So we have a lot of data set. We can get those data set and then start practicing predictive machine learning or machine learning data science with those data. While we are practicing, then we start putting our head on, okay, how can I replicate this data from my laboratory or from my field work or from my student field work? So having those online data set, we have several of them. We've shared some of the link before, and we're going to share it again. We have several data sets like UCI repository. We have a lot of data sets in their own. They're going to tell you not just data, but who has used the data before for publication so that you can easily know who has used it and who to reference and where to look for further research ideas. And there are so many others. We have some government parastatals all over the world that have mandated their agency to put their data online. We can always get them first as a starting point. And the good news is, as a researcher, we can actually use those online data for publication. Yes, we can use them to publish even in top tier journals because it is what you are bringing on board. Somebody might just get the data and put it online and never use it. We have several cases like that. Very nice and wonderful data. They just put it online. No one ever use it. And then someone pick it there, do analysis with it, discuss it, and then share with the research world. Publish in Q1, Q2, as the case may be, or Scopus. Even though it is online, it is very valid for us to do research with it because we want to advance frontier of knowledge. We want to call people to look, this data that is here wasting away, we can actually make use of it to do something. However, the only issue now comes when we want to localize the implication, the effect. No, there's no data that can guarantee that a data got it from a particular another country may not work in another country. Yes, this is the challenge of data because their own soil is different. So, but there's no harm in trying it first. After we have used it, then we get our own local data. Our students, we keep getting it, gradually combining them. And then we now see what can we do in our own local. We have done it on the online one that came from somewhere. Sometimes you don't even know where it came from, but a good data will describe where the data came from and how they got the data to make it trustworthy. So that, and if it is actually generated data, some people use software to generate data, they will put it there that this is a software generated data, it's not a real life data. But mostly, most of those data sets out there, they are real life data, which means if we can model it successfully, then we can think of how can we replicate the same data in our own local parlance. Because the local data is very important. It's more relevant to the one here. But we are looking at a higher level of machine learning modeling that data will be irrespective of where it came from, but that is tough. We call it heterogeneous database modeling, where you bring data from another source, the one from local, you can try to mix them together, divide it to training and testing, and then see if you get good result. Or bring 3 from local, another 3 data from another place, try to use 2 from 1 from 3, 2 from local, 2 from foreign, combine them together for training, use 1 from local, 1 from foreign to test them. These are some of the new ideas we're trying to see. How can we make it work? But it's very, very tough. So data is local because the characteristics of the local environment will influence the kind of data that we are gathering. Another good news in respect, in relation to the question of our professor, is that data does not have to be thousands before we use it. If the one we just demonstrated is just 157 samples, 157 samples. We've had data in some of the material modeling. Data is not always very much available, very scarce. Sometimes we have to go into publication to extract data from papers. This guy published a paper, he put like 5 data there. We remove that data point. Another paper published a research idea on the same issue. He put another 5 data set they are analyzing. We put all of this together. Maybe we are able to get like 32 samples. We were still able to do modeling depending on the area. So we go for algorithm that has propensity to perform in the face of few data, like support vector machine. If the data is very few, it's still able to do some things. Even k-nearest neighbor also is another example that when the data is fewer, it may also still be able to do it. But the more data we get, the better. However, any little we get, we can start working with it until we are able to get more data. And we also have to encourage our people. The government need to come up with policy to encourage agencies, departments, and even universities to put their data in their database and after some time online. A university that has a good data repository online, we attract a lot of traffic to their website, which is one of what they use to measure the popularity of university. Imagine a university decide to build a database of medical data. People will come from any over the world to search for their data online. That is why UCI repository is one of the most popular data center in the world. And it's a university that decided to make a lot of data sets available for people. When you are starting machine learning research, you can't do without going to UCI repository. And it's a university. So we can also try to look into this. How can we produce data? The data are there in the laboratory, maybe in manual form. When we go to farm, we record this data, but we are not making it in digital form. So we need to encourage it, and we need to work on that. Thank you very much, Paul. Okay, another question? So I believe that's the question we have for the day. Once again, thank you very much all for coming. Dr. Mujisola, are you there? So if there's no other question, I think we can call it a day. Thank you very much once again for coming, and we wish us all the best. And let us try as much as possible to spread the message. Let us encourage people as much as possible to take benefit of this. Our aim and objective is machine learning for all.
Sir.
Yes.
Good morning. Thank you very much for the beautiful presentation. Unfortunately, I got the notice very late and I joined very lately towards the end. Please, can you please advise on the software you are using for machine learning? Is it MATLAB? Is it R or whatever? Please, sir, can you advise on that?
Okay,
And can you make this presentation available after this?
Yeah.
Probably the recorded presentation. Can you make it available, sir, so that it can benefit those of us that came late?
That's okay. Well noted.
Join the
Yeah,
Zoom team.
usually
Thank you,
all
God.
our videos, you are welcome. So I believe so if a volunteer will share with you maybe on the chat group, link to our WhatsApp group where you can find all necessary information about this weekly program and all our archive. We also have YouTube channel where we have recorded videos of every section we've had in the past. We've added, and this one also is not going to be an exception. As soon as possible,
Right.
it's posted for us to benefit from. Regarding the platform we are using, we actually use Weka platform, W-E-K-A. W-E-K-A. We can search it. It's a very simple.
W-E-K.
W.
Yes.
Yeah. W-E-K-A. So.
Okay.
Yeah.
Okay, what will happen is that probably I will share my email address so that we can also exchange some information after the meeting, sir. But W-E-K is.
Hello, Prof. I posted the link to the WhatsApp. Just join the WhatsApp group, then you take it from there.
Yeah.
Just
Okay,
join
sir.
the WhatsApp group, take it from there.
Thank you very much, Dr. Mujisola. They say join the WhatsApp group. You'll see all the necessary information will be provided for you. However,
Right,
we are currently not using R. We are not using Python. So I'm using Weka, MATLAB, Python, R. Yeah, they used to be what we use for our experiment as computer science, people with computer science background. However, in this platform, the idea is machine learning for all. So we have people from different background, medical doctor, different fields of study. They are not computer programmers. If you ask them to go and be learning computing, programming, before they use machine learning, some of them will drop along the way because programming is another thing. Machine learning is another thing. This has been one of the impediments to people learning machine learning and AI. People always want to pass through. They want their student to pass through the programming route, which is not always easier. So our idea is that we call it no coding AI. We started the idea almost 5 years ago, no coding AI, that you can actually use machine learning, deploy it, build models or AI system by using click, or drag and drop capability on different AI platforms. And since last year also, we started seeing that even Stanford University started advertising no coding AI because they also now realize that this is the way to go, even though we started ours almost 5 years ago. So that is, we don't really teach people programming, because programming is different from machine learning and AI. If you know programming, that's an advantage for you. However, multitude of people may find it difficult. I love programming because I'm a computer background person. However, for people who come from other areas, we have hope for them that you don't need to run away from machine learning and AI because you don't know programming. You can do a lot of wonderful things in your own area of specialization without writing a single code. The platforms are available. One of them is Weka. We have a lot of other platforms also that you don't need to write code before you can make use of them. So you're all welcome, and I wish you all the best. You are welcome to the platform and every other new members. And like I said, spread the message. Let your friends also take benefits. The essence is for us to reach as many people as possible so that together we can all take positive advantage of these technologies that is changing the world and the way we do things. We can't afford to be left behind. So I say positively. That's why we encourage what we call ethical and responsible artificial intelligence. We look at the positive aspect of it while avoiding the negative aspect of it. With this, we say thank you very much for coming and wish you all the best. Thank you very much.
Thank you very much, sir.
Thank you, Professor.
We appreciate